Alright, in this video we're going to take a look at question 1, parts 1 and 2 for assignment A. So question 1 says, a server receives packets of length p bits and retransmits them by adding a header of h bits. What is the transmission overhead of the server? Part 2 asks, consider a network of 6 servers in tandem, and we see here a 6 server network that looks like it's daisy chained along. When SI receives a packet of length P bits, it retransmits it by adding a header of length HI bits. So what we can say for sure is that each HI might be unique. That means to say that H1 does not necessarily equal H2. Maybe. It might not, who knows. Either which way, what we know for sure is that they're daisy chained together. So a packet can enter the network only from S1 and exit only from S6. So just in case it wasn't completely clear that they were daisy chained, we have a little bit of extra information here to let us know that. And it says, what is the transmission overhead of the tandem network? So part 1 leads into part 2. Both of these were worth 5 points. And let's take a look at what part 1 requires. So let me make sure that this is visible. So part 1, we get the given information. So we'll write down given. So what are we given? We are given packets of length p. So this is the length in bits of a packet. We are also given a header of length h. So this is the header length in bits. Okay, so if I draw out one of these such packets, I can just take the sort of standard representation of a packet. Now, I don't know exactly how long the header is or how long the body of this packet is, but I will assume that the body of this packet will be longer than the header. So I'll draw this. I'll say this is our header. This is the body, and all together this makes P plus the header, right? I could have just said that this was P because we have packet of length P bits and then we add the header onto it, so this would be P plus H. So let me get rid of this body content. So it says here, what is the transmission overhead? Well, the question now is, what do we mean when we ask for transmission overhead? What's the definition of a transmission overhead? Well, simply put, the overhead to transmit is how much I need to add onto my packet with respect to how much I have in my packet. So if I have to think about that, if my packet is P long and I have to add on top of it H bits to get to my networked packet, my output, I would say that my transmission overhead would be whatever H exists, whatever header has to be added on, divided by my packet. Okay? So, pretty simple problem. Just a little bit of thinking. It's the ratio of how much has to be added on top to what I want. Okay. So this is part 1. Alright, so this is just like efficiency, right? Anytime that we look at efficiency or any sort of calculation, we think how much do we need to add or how much is lost in terms of our overall transmission amount with respect to what we actually want to be transmitting. So the overhead is whatever I have to add divided by whatever I want, whatever I'm desiring. So that should be pretty simple. I hope it comes into focus. I hope this is easy to view. Looks like it will be. So okay, now that we have part 1 done, we understand that we have the transmission overhead, which I will call TO. So now that we know that the transmission overhead is H over P, we can take a look at this daisy chain network and see what's required of that one. So okay, let's take a look at this, right? Part B. So now we have 6 servers in tandem. Each one adds its own header. So let's take a look at it like this. Let's look at what happens at S1. The packet that comes out of S1, so this is the packet, will be H1 plus P. And that will go into S2. Put some circles around these. And what comes out of here is going to be H2 plus H1 plus P. And so on, right? So what's my overhead here? It's going to be whatever number of servers I have. So if I have 6 servers, I'll have 6 additional headers. So it'll be H6 plus H5 plus H4 plus ... plus H1, all of that divided by P. Now, what's going to be our worst case scenario here, right? Like, every time I look at a new server, what comes out is going to be P plus H of the previous, right? So if I look at what goes into, or what comes out of this, some people might want to consider the packet that went in to be H1 plus P, and that's our new packet, what I'll call packet 1. That is a possible way of looking at it, but given that we know at the end, right, like we know exactly which piece belongs to H1, H2, right, and what belongs to this P, there's no reason for us to encapsulate the previous headers as the input in the actual server that we're looking at that time. So there's no point to add H's down here. But that being said, it's also a possibility, right? Because there's that possibility that at this server we don't have knowledge of what's header and what is packet. That's a possibility depending on the type of switch, what kind of server this is. Now, if we assume it's a server, we assume it has full computational capability, and we can assume that it's not just storing and forwarding. So there's a lot of different ways to look at this problem that are all valid, depending on how you've written your answer, but the simple answer is it's all of my headers over my packet. Okay, so that's question 1 in a nutshell. We'll come back in the next video with question 2.